I think we are live now. No, I think we are live now. Can someone confirm before we start? Okay, thanks. Let's get started. We'll start with the easier problem and I will also try to code problems this time. Okay, so the first problem is we are given three digit ABC and two of them are equal. The third one is different from the other two. Find the value that occurs exactly once. And and if we look at the samples, like in the first sample, the example is 1 to 2, like 2 appears two times. So like is voice better? I think the voice would. Hello? Let me just check my stream. Says it. Hello? Is voice okay? Is voice better now? Like, is it still echoing? Hello? 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 What? It's like found the reason for the echoing. Yeah. So like, let's get started from the first problem. We are given three distinct integers a, b, c, and we are given that two of them are equal, and the third one is different from the other. And we have to find the value that appears exactly once. Like, and if we look at the first line contains the number of test cases, and the second line contains three integers in each line, and we have to find which two of them are equal. If we look at the samples now, like first sample says 1 to 2, here we can see that 2 appears two times, so we should output 1 over here. And similarly, if we look at 5, 7, 5, 5 appears two times, so we should output 7 over here. So like I will directly jump on to the code for this one. So what we can do is we can first take three integers as input over here, and then we can either manually check it over here. Like for example, we can either create cases like this, like if n is equal to if n and m are equal, then we know that the third distinct integer is k. And similarly, we can create more cases over here. If n and k are equal, then we know that the third integer would be m. And if k m n are equal, then we know that the third integer would be n. So and we can do this like this, and we can now try to submit it on Codeforces one. And look. And second problem statement says not quite Latin square. A Latin square is a 3 cross 3 grid made up of letters ABC such that in each row the letters ABC each appear once. In each column the letters ABC each appear once. For example, one of the Latin square given to us is ABC, CAB, BCA. Now we are also given a Latin square, but one of the letter is replaced with the question mark. We are They are asking us to find the letter that was replaced in the Latin square. And if we look at the sample over here, the example is ABC C question mark B BCA. Like this is the square, and it claims that instead of question mark, the letter should be A. Like we don't need a lot of properties over here. Like for example, what we can do is we know that for each row, the letters A B C appear exactly once. because we know that the total rows are 3. What we can do is we can count the frequency, like we can count the number of times each letter appears. And what we can know is that like the number which is missing would be appearing 2 times. For example, if you look at this sample, if there is a question mark like in this sample, like we can see that A appears 2 times, B appears 3 times, C appears 3 times. Similarly, for the next sample, what we can see is like B appears 2 times first and the last line, C appears 3 times, and A also appears 3 times. So if we count the number of times each letter appears in all of the 3 strings, we would be able to find the missing letters. Like there are many other solutions as well, and this is one of the possible solutions over here. And I will jump on to the code for this one. Like there are many ways to do this. The easiest way would be we can create a map, and we can try to like we read the string, like we know that there are 3 strings for each output. We run a for loop 3 times. We read the input in a string, like, and then we can create a frequency map. And once we have created this frequency map, we can iterate on it. Like, and we can try to submit it on Codeforces once. Algorithm is we read the 3 lines of input. We take input in a string and we add the number of characters each appears in a frequency array map. We can also use hash map, or there are many different solutions for it. And at last, we print the character which appears 2 times. Because of the input, we know that like only one character will appear 2 times. And yeah, this looks good. Any questions on this one before I move on to the next problem? Like, should I explain samples more? My Jaw solution was mostly abusing the fact that if a question mark appears, and like basically the first part only, like probably we have seen in lead code problems, right? Where like one of the famous lead code problem is like we are given an integers, one of the number appears, probably like we are given n minus one integers, one of the number appears 2 times. So if we XOR them, like they cancel out each other. And my idea was like if there is a question mark, then that question mark will contain two of the other characters in it. Like what I started with was, so like I know that the string will contain three of these characters over here. So if the string does not contain question mark, I remove it, and if it contains question mark, I cancel them out over here. So like at last, I know that like only the missing character would be the value of C over here. And like similar solution was for A as well. Like we know that each number appears 2 times. We can, if we take the XOR of all the 3 numbers, like XOR has a property, like if you do a XOR 2 times, they cancel out each other. Like this was the idea for the B1, and probably now I will start the next problem. Like it says, can I square? Like Kalin has n buckets, height of which contains AI wooden squares of side one. Can Kalin build a square using all of the given squares? So like the problem, and if we look at the sample, like in the first example, we are given that there is only one bucket and it contains 9 square. So like what we know is like we can like first let's look at what's the property required to create a square over here. Like if we want to create a square of length x, and what we know is we will need all 1 cross 1. Let's say x is 4. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like if we want to create a square of size x, we need x square number of stones over here. And the problem statement asks us, can we build a square using all of the given square? So like what we first we will need is the total number of stones we have. And once we have counted the total number of stones, we will have to check, can we create a rectangle using them. Example, we know that if the total number of squares are 27, let's say, then we know that none of the square contains 27 as its area. Like the nearest one would be either 5 into 5, which needs 25, or the next one would be 6 into 6, which is more than 27. So what we need is, first we take sum of all ai, then we need to check if there exists an integer x such that x into x is equal to sum. Like the easiest way to do it would be like we can use the built-in C++ function. But like it's the catch, like since it's a diff round, like there is a catch of using like square root function to find the square root of a number. Can anyone say like what would be the possible catch over here? Why only using code like this will fail? Yeah, right. Someone correctly said precision. Like one of the possible way to do it would be like we take everything as input, we find sum of all integers, and then we can just check if like someone might have tried a solution like this and this will get a wrong answer over here. Like let's go ahead and submit it once. Fortunately, it got an AC, but yeah, the problem overall here is like if we try to like there are often precision issues over here. For example, if I try to find square root of and like probably like it would be good if someone gets the W and then learns it, but there are precision issues with it. Like this is not the best way to find the square root of a solution. Like a better way would be to first do this one, like find the square root and then run a while loop which decreases the number if its square root is lesser, if increases if it's, and at last check if x is equal to this. Like some people even do round over here. Like in this problem, it might get an AC, but like it's a way to look at like this creates problems over here. So, like this was C. Like any questions on this one before I move on? Like and probably we can look at the samples one. Like in the first sample, like oh there sum is 9, so it's a perfect square. In the second sample, sum is 16, so it's a perfect square. And in the third sample, one can verify that the sum is 15, 21, 28, and it's not a perfect square. In the third sample, sum is probably 25 or something like that. And in the last sample, the sum is 8. So probably I will move to problem D if there are no doubts on C. Like unnatural language processing. Like, okay, problem D says Laura was bored and decided to make a single language using five letters A, B, C, D, E. There are two types of letters: vowels, letters A and E, they are represented by V. Consonants B, C, D, they are represented by C. There are two types of syllables in the language: CV, consonant followed by a vowel, or CVC, vowels with consonant before and after. For example, BA, it's consonant vowel. CED, CED is consonant vowel consonant. BAB is consonant vowel consonant as syllables, but AA, EDA, BABA are not. In a language is a sequence of syllables. Laura has written a word in a language, but she does not know how to spell it with syllables. Help her break the word with syllables. For example, BACE, DBAB, it will split into syllables BACED, BAB, where the dot represents a syllable boundary. Like, probably, I will try to simplify the problem statement once. Like, first sample is probably given an input as well, but I will try to write it again. It says BACEB, DBAB. Like, this is a word, and we have to split it into us. Like, we have to add some full stop somewhere. Like, one possible way probably can be to do it like this. Says that between each full stop, either the words are of form consonant vowel consonant, or the words are of form consonant vowel. And then we have to find one possible way to split the given string into words like this. Like, for example, if I pick the third sample, let's say, which is EAD, EEC, ABE, ED, AD. Let me just randomly split it with some dots, like let's say this. And if we try to check if this is valid, like first is a consonant, then is a vowel. Fine. Second is a consonant, third is a consonant. So like this way of splitting into dots is invalid. We can also check the other one. It's vowel consonant, this is invalid as well. Vowel consonant vowel, this is invalid. And BE consonant vowel, this is valid. DD is consonant consonant, it's invalid. And then we can see like vowel consonant, this is also invalid. And like let's also look at the example which was given over here, like the answer for this problem. Answer says the correct way to split it would be DAD dot PE dot PA dot PED dot PAD. And if I try to find like consonant vowel, like D is consonant, A is vowel, D is consonant, so it's valid. E is consonant, E is vowel, it's valid. E is consonant, A is vowel, it's valid. E is consonant, E is vowel, D is consonant, it's valid. E is consonant, A is vowel, E is consonant, so it's valid too. Like this is one possible. And all the problem statement also says to us, if there are multiple possible ways of splitting, output any of them. And the input is given in such a way that at least one possible splitting exists. So one fact on this problem, although that like this statement is misleading, for any possible string, either there would be only one way to add full stop such that it's of valid syllabus, or it won't be possible to create it at all. Like any questions on the problem statement first before I move on, like how to solve this problem. Okay, like I will try to move the solution now. Like one greedy idea is let's see like we have something over here. And if the last character is vowel, then what we know is like like there are only two types of syllables. One which ends with the vowel and one which ends with the consonant. So if the last character is vowel, then this would be the type of syllable over there. So if the last character is vowel, we should only take last two characters and try to recursively find for the remaining string. So the answer of this short like this string. And if the given string contains ends with a consonant, then the only way that this string is present in a syllable is via this type of syllable CVC. So we should pick last three characters, and because the problem statement says there is one way to do it, we can take the last three characters, split them out, and try to find for the rest of the string. Like that's how we do it. Like any questions on this greedy idea before I will after that I will try to code it up once. Like I see some people have tried some recursion or something, but like this was the way to do it, and recursion would have worked because like there is only one way to do it. So like all the other ways would have failed. Like we need the number of test cases to input e and string s, and then we can try to create the string answer string. The way to do it would be for start from last index. While we have a part of string to still process. If our last character is a vowel, there are two cases like either the last character is a vowel or the last character is a consonant. If the last character is a vowel, then we know that it's of form CV. Because we are given that there is at least one way to split, we can, and we also know establish the fact that there would be only one way to do it. So we can just assume that the second string is a consonant over here. We can also add a check if we really want. I will create the string in reverse first and then reverse it. Or if the last character is a consonant, then we know that the way to form it would be CVC, and we can assume that the second last two characters are C and V only. So we can pick the last three characters. Like this will create a string in reverse form, and there would be one extra full stop as well. So we should remove the last full stop which we have added over here. And now we should reverse the string as well. Like this would be the code for it. Like there are ways to do it from starting as well, but that will involve some non-trivial amount of code and then creating some DP variable I, which says can we create a string up to I, or can we create a string up to I minus 1, and then there are cases based on that. Like this gets an easy. And probably I will move on to E problem now if there are no more questions over here. Okay, moving on to problem E now. So the problem statement name is romantic glasses. Like probably the name is Julia or something else. I'm not really sure. Let's call it Julia. Julia has n glasses arranged in a line. The ith glasses has AI units of juice in it. Julia drinks only odd numbered glasses, while her date drinks only from even numbered glasses. To impress her date, Julia wants to find a continuous subarray of these glasses, such that both Julia and her date will have same amount of juice in total if only the glasses in this subarray are considered. Please help her to do so. And then it says more formally, find out if there exist two indexes L and R, such that one is less than equal to L, is less than equal to R, is less than equal to N, and AL plus 2 up to AR is equal to AL plus 1 plus AL plus 3 up to ALR minus 1 if L and R have same parity, and AL like otherwise there is some other definition. And then there are some samples as well. Like let's start from the samples first. In the first sample, the statement is 132. What we can, the answer is yes, and what we can do is we can take the complete array. Like Julia will drink juices from 1 and 2, the sum is 3, and her date will drink it from the subarray 3. In the second, we can just choose the first two. Julia will drink from this one, and her date would drink from this one. And like we can try to pick this sample as well. Like probably way to do it would be 1 second. The answer is yes, right? Yes, the answer is yes. 1, 2, 3. Okay, it's given here as well. What we can do is we can ignore the first string and we can drink all the odd number from L to R. So she will drink A3, A5, A7, which would be 11 plus 1 plus 1, 13. And her date will drink A2, A4, A6, A8, which would be 2, 4, 5, 2, which is 13. So like probably like problem statement introduces a lot of definitions over here. Let's try to simplify it once. Like let's first forget about all the definitions and what would they drink if they do everything over there. Like what's given to us is that A1, A2, A3, A4, A5, let's say A6, and this is the given array. And let's say the subarray which they choose for drinking is this. So from this, what we know is like Julia will drink from these two, and her date will drink from these two. And what we need is we have to find one such array such that, for example, A3, A5 is equal to A4, A6. And we can try to simplify it again. Like let's say we move this part over here. So instead of saying that like sum of odd indexes plus sum of even indexes is 0. What we can say is that if we multiply by plus 1 for all the indexes and multiply by minus 1 for all the even indexes, then the sum of sub arrays should be 0. Like if we pick the definition from the problem statement, like AL, AR, everything, like if we move everything to the left hand side, like it becomes moving everything to the left hand side. Like you can try out both the definitions which are given over here. We can also multiply it by L to the power minus 1, like this complete array. So that this multiply, so that this becomes minus 1 to the power L, AL, plus minus 1 to the power L plus 1, AL plus 1, plus minus 1 to the power L, L plus 2, AL plus 2, so on until minus 1 to the power R, AR equal to 0. Now, once you have noticed this, we we have an idea of prefix sum array. Like what we really need is, like if A1, A2 is the given array, multiply AI, replace AI with minus 1 to the power I, AI, and we have to find some array such that its sum is 0. And the idea to do it would be using prefix sums. Like for example, if we create a new array, let's say, like if we have A1, A2, like let's call it B1, B2. If we create a new array Pi such that the index up to I is, let's say, sum of first I number. Like for example, we create a new array where P0 is 0, P1 is P0, like sum up till the first index B1, P2 is the sum of first two numbers, P3 is the sum of first three numbers. Like that's what people call suffix array. A array which the ith index of that array contains sum of first I elements of an array. To be here. And if we go to our previous definition, like what we have reduced is we need an array such that sum for the elements in B is 0. What we can notice is that we can write it as sum of first R elements minus sum of first L minus 1 element. Like by adding and subtracting, if we add this and subtract this, the array becomes like sum of first R elements minus sum of first L minus 1 element. And now if we see, like the problem is reduced to checking if there are two equal elements in the array P which we have created. And if they exist, then the answer to our question would be yes, otherwise no. Like any questions on the idea before I try to code this part? Like I will move on to coding this one. Like take n as an input. Like I am following one base index. Now multiply each by I to the power j, like creating an array B now. Like we know that if I is odd, then I minus 1 to the power I is minus 1. Now we can also create prefix sum array. Like prefix sum of 0 would be 0 only. And right, if we create I, then prefix sum of first I element would be sum of first I minus 1 elements plus the ith element. And now what we need to check is if this array contains duplicate elements. We can also do that using some set. If this sum has appeared, like if the sum so far appears 2 times, we can maintain a flag is possible which is false initially. And if a sum appears 2 times, we mark as is possible equal to true. And then we again insert this element over here. And at last, if possible it's true, print yes or print no. Like F would be the next problem which I would be taking up. Like going through our idea again, we first take array as input, then we multiply every element by minus 1 to the power I. So for odd, we multiply by minus 1, for even it remains same. And then we create prefix sum array where the ith element denotes sum of elements up to I. But so like for finding the sum of first I element, we take sum of first I minus 1 element and add ith element to it. And then we have to check if this contains duplicate element, which we can do it using a set where we maintain all the elements so far, and if it exists, we mark as true and we maintain it. Like any questions on this one before I move on to F now? Okay, so someone asked me to explain again, like how does the presence of duplicate element denotes it's possible? Like, I will probably go through my solution once again. In the original array, presence of duplicate does not denote it. We try to do some modifications on it to create a form which says like presence of duplicate denotes all that. Like going over to the solution once again. Like if we take the problem statement, it says al plus 1 al up to ar is equal to al plus 1 al3. Like there are two definitions. I have taken one of them. You can take the other one. And if we move right hand side to the left hand side, this sum changes to al minus al plus 1 plus al plus 2 minus al plus 3 and so on. And if we multiply even this one by minus 1 to the power l, then this sum changes to a minus 1 to the power l al plus minus 1 to the power l plus 1 al plus 1 and so on equal to 0. Now based on this form, what we do is first we create a new array b which is minus 1 multiplied to the power that element. Then this given summation changes to this becomes bl, this becomes bl plus 1 to br, and whole problem reduces to checking if bl plus 1 plus bl plus 2 up to br is 0, where bi is minus 1 to the power I ai. Like it was trying to, when I was trying to manipulate the given identities over here. Like when we are given this identity, like if we move this part to the left hand side, and then we multiply complete array by minus 1 to the power l, then this would be the form we will get. And then we created a new array bi, where bi denotes minus 1 to the power I ai. And now we have came up with the form, like we need some array such that whose sum is 0 in b. And then for even for this part, what we can do is we can add numbers up to b1 b2 up to bl minus 1 and then subtract them as well. And if we now notice this becomes sum of first r elements of b, which we have denoted by prefix r, and this is sum of first l minus 1 element, and the whole identity changes to pr minus pl minus 1 equal to 0, which again denotes pr equal to pl minus 1. So like that was the idea. Now moving to problem f now. I think like looks like you understand. Like problem f says there are n people on a number line. The ith person is at point ai and wants to go to point bi, and we are also given that ai is less than bi, and the starting and ending point of all the people are distinct. That is, all of the 2n numbers a1, a2 up to bn are distinct. All the people will start moving simultaneously at speed 1 unit per second until they reach their final point. When two people meet at same point, they will greet each other once, and we are asked to find how many greetings will be there. Note that a person can still greet other person even if they have reached their final point. And if we look at the example ones, like one person starts from 2 goes to 3 and one person starts from 1 goes to 4. The answer is 1, like they will definitely meet. So like let's try to simplify it first. there is a number line and there are different points marked to it. Let's say 6 points. And someone will start from one point and like if there are 6 points, three people will start from some point and go to some other point. Like for example, someone can start here, go up till this point, or probably let me try to pick some other. Like someone starts from this point, goes up till this point. Someone starts from this point, goes up till this point. Someone starts from this point, goes up till this point. And we are asked like, and if we notice over here, like no one will meet this person, but whoever is starting from this and goes until this point, like after like let's number this position as well. And one goes from 1 to 3, someone goes from 3 to 6, and someone goes from 4 to 5. So like after 1 second, like the first person would be at 2, second person would be at 4, third person would be at 5. And one more second later, since 2 and 5 have reached their destination, they will not change their position and 4 will go to 5 again. So here we can see that the second and the third person have met once, and even 1 second later, like their position would be, and our overall answer would be 1. Like any questions on the problem statement? Like we are given starting and ending point of some people, and we are asked like, someone will meet if they go from one position to the other? We can probably pick sample again. Like here we can see one starts to two, from 1 to 2, second 3 to 4, 5 to 6, and 7 to 8. And what we know is that no one will meet over here. And like here no one will meet. If there are no questions on the sample, then like if we try to see like if we look at two different people, let's call someone xi who starts from and goes up to yi, and someone starts from xj goes up to yj. Like what is the necessary condition that they will meet? Like if the starting and ending points are like this, they will definitely not meet. But if the starting and ending points are like this, they will definitely meet. If the starting and ending points are like this, then also they will definitely meet. Like this is the case when they will not meet. This is the case when they will meet. So this is the case when they will not meet as well. Sorry for the confusion. Like they will not meet for this case as well, because the speed at which they go is same. So if some like every time that initially this distance will remain same, and at last when one of them has reached the destination, like they will even go further, but they will definitely not meet. So this is the only case when they will meet. This is the case when they will not meet. And once we have found this observation, like so the necessary condition is if xi is less than xj, then yi should be greater than yj, and vice versa. If xi is greater than xj, then yi should be less than yj. Like if you look at it, these conditions are pretty much same with I and j swapped over here. And now, like once correctly pointed out, simply cap the number of people who have destination greater than destination of ith person. And then using ordered cell, calculate the number of people with starting position. Like that's one idea. Like the one way to do it is if we sort all the elements in the increasing order of x, such that x1 is less than x2 is less than xn, then the condition reduces to for each element. Like if we sort points like this, then for any I less than z, this condition should be satisfied. So to count the number of inversion, we just need yi less than yi. Repeat the idea again. If we sort points such that x1 is less than x2 is less than x3 until xn, then for each I less than j, we should count the number of points yi greater than yj. Like I will first try to code a brute force solution for it that will get it yearly, but to give an idea on this one. I took all the numbers as input, sorted such that like the default order makes it in the increasing order. This will get it yearly. Okay, sorry. Like I can open my code again. Like I first read the number of test cases and then read input e and then read all the points. And then I sorted all the points such that x is in increasing. That was the first part to it. And then I ran a for loop where I equal to 0, I less than and I plus plus. Like I will also add the code link for all of my submissions in the description as well. And like ran two for loops and then checked if AI is less than age in surplus. Like someone asked like why do I use long in for loop? What I have seen is like the memory limit for int and long does not make much difference. Using long everywhere just avoids int overflow issues over there. Like as expected, this did got it really. And if we notice one thing, like after sorting, like if we can also create a new array yi, which is the y coordinate after sorting the points. And what we know is like for example, if y coordinate looks like this, 6, 5, 7, 3, 1, and then the number of meeting points would be like nothing on the left of this, For 5, one element is greater than it, so add 1 to it. For 7, nothing is in between. So like the number of meeting points so far is 1. For 3, 3 points are greater than it. So like 3 will meet 3 people. And the answer would be 1 plus 3, 4. For 1, there are 4 people to the left of it. So the answer would be 4 plus 4. Okay, 1 second, it was 10, sorry. So the answer would be 8. And if one notices, like this problem is same as counting the number of inversions in an array. Like you should practice this problem once. Like there are many solutions to it, and like this is one of the problem which appears many of the time. I will add its link once. And the next part was trying to optimize it. Some people use ordered set for it. Like some people did coordinate compression and then a Fenwick tree or segment tree, whatever they call. And like probably I will keep that part as a homework. Like if you want, I can code one way using which I did it, but I think that would be a night exercise to practice for. I can do it once if like people want to see like one solution for it, or I can just share some links of different articles where you can learn about it. Probably for template, I will try to add something over there. Like I did just created it sometime, and like I can try to add like like so yeah. So I will probably leave it and like I will share some ideas, like some articles on it and some other YouTube videos where you can learn about the coordinate compression. And in the interest of time, I will move on to the last problem for today. It says bicycles. All of Salvik's, like I will add the link in the comment description of how to do it coordinate compression. Like bicycle, all of the Salvik's friends are planning to travel from place where they live to a party using their bike, and they all have a bike except Salvik. There are n cities through which they can travel. They all live in city 1 and want to go to party located in city n. The map of cities can be seen as an undirected graph with n nodes and images. As I connect city UI and VI and has a weight WI. So far it's just is that we are given an undirected graph where there are m edges and each edge has some weights to it. And then comes the interesting part to it. Salik does not have a bike, but what he has is money. Every city has exactly one bike for sale. The bike in the city I has slowness factor SI. Once Salik buys the bike, he can use it wherever to travel from city he is currently in to a neighboring city by taking WI equal to SI time. Considering that the traversing edge from I using bike J he owns. Salik wants can buy as many bike as he wants as money isn't a problem for him. Since Salik hates traveling by bike, he wants to get from his place to the party in the shortest amount of time possible. And since his informatics skills are quite rusty, he asks you to help. What is the shortest amount of time required for Salvik to travel from city 1 to N? Salvik can't travel without a bike. It's guaranteed that it is possible for Salvik to travel from city 1 to any other city. So like I will try to explain this problem statement first. I will pick the sample only. So for the sample we are given is there is an edge. Like Salik has a lot of money, he can keep all the bikes he wants. Like for example, the given sample is from one. There is an edge of weight two between one and two. There is an edge of weight one between one and three. There is also an edge between two and four of weight five. There is also an edge of weight one between four and five, and there is also an edge of weight seven between two and seven. And the first place has a bike of slowness 5, second place has slowness 2, third place has a slowness 1, fourth place has a slowness 3, and fifth place has a slowness 3. And like one way to do it is like Solid first takes the bike with slowness 5 and goes from 1 to 2. So the total time taken here would be 2 into 5 in second time. And he can purchase the bike at over here, so that his slowness is 2 over here. And using it, he can go to 3. Since the distance is 1, the total time taken would be 2 into 1, and the total time so far would be 12. He can purchase the bike with slowness 1, and using it, he can go to 3 to 2 back again. Now, this time he will take 1 second. Total time so far here would be 30. And then he can go from 2 to 4 with the slowness factor of 1 using the bike he purchased at 3. Like although he has this bike, he don't really need it. This time it will take 5 seconds and total time would be 18. Because the slowness here is 3, which is less than more than 1, he will not purchase the bike here, rather he will keep using his current bike. And then he will go from 4 to 5 in 1 second and slowness is 1. So overall the time taken would be 19. Like there is no explanation in the sample, I will summarize it once. He will go from 1 to 2 with bike of slowness 1, total time would be 10. Then he will go from 2 to 3 using a new bike which we have purchased here. Like initial bike would be 5. Then he will purchase a new bike over here. And like here the time 2 to 3 is 1. So like here the time taken would be 2 and total time would be 12 and he will be at 3. And he will purchase the bike with slowness 1 again. Probably I can use different colors to denote different. A new bike to go to 3, which will have slowness 2 and distance 1. So he will reach here at time 12. And he will purchase a new bike at 3 with slowness 1. Using it, he will go to 2. His distance is 1, he will reach 13 at 1. Then using the same bike, he will go to 4. This time the time taken would be 5 into 1 total at time 18. And then he will use the same bike to go to 5. The distance is 1, so time would be 19. Like any questions on this one, like what does the problem statement ask first before we try to solve it? Okay. Now, like one thing we can notice, like moving to solution part. One thing notice it like Salvik will buy a new bike only if the slowness decreases over here. In this case, he started with 5 first, then he purchased a bike with slowness 2 at 2, and then he purchased the bike with slowness 1 at 3, and then he kept using it. So if we try to generalize it, Salvik will start with bike with some slowness, let's say S. He will travel some cities to reach a new node where the slowness would be less than, let's say, probably I can take numbers over here. Like some artificial number. Let's say if Salvik started with slowness 10, then he will go to some new city. There he will buy a new bike with slowness lower than it. Let's say 8. Then he will again travel some cities, try to buy a new bike with let's say slowness 6, and then he can travel some more area with a new bike with let's say slowness 4, and at last he will go to the destination N. Like this would be the starting. And let's say whenever he wants to travel from some city to the other, like here in this case, what he should do is he should travel along the shortest path between these two nodes. Like if someone is going from U to V, he should go on the shortest path from U to V as soon as possible. So once we have found these observations, what we need is first we need shortest distance from each pair of nodes. Let's call it this I comma j. Like there are many ways to do it. One possible way to do is start n times Dijkstra from each node 1, 2 up to n and find the shortest distance of every other node. And once we have done that, what we know is that we will always go to the smaller node with like smaller slowness, right? So let's say if we write an array dp which denotes the shortest time taken to go from 1 to k, then we can try to compute these values in decreasing order of slowness values. So the idea is like we don't have to do anything to go from 1 to 0. And decreasing order of Si, first from all nodes I go to dpk, that slowness is Si, and then go to all the nodes again. Like, like I can try to show it using my code over here. Like if there are any questions from this explanation, I can take them up. Like any questions like how are we computing like slowness bike and everything before I try to code this problem. Okay. Or probably we can let's try to introduce 2D array one. Like can you show the reasoning for slowness in decreasing fashion? Like that idea is greedy. Like let's say if Salvik has a bike with has slowness 10, then he, there is no reason for him to purchase a bike of slowness 11 and switch it to 10 because that will only increase the distance for all the edges he goes. Like if Salvik has a bike with slowness 10, then he should only go try to purchase a bike with 9. Changing from 10 to 11 will only increase his weight over here. It will not decrease the time taken because slowness increases over there. Or probably let's say introduce a 2D array over here and then move it to 1D array. EP as denotes the number of the shortest time taken to go from 1 to j, such that when you have reached j, the bike slowness is s. And we can initially populate dp s1 1 s0, and then we can try to purchase new bike and go for it. So like if we want to put say like let's say DP10 is 0, then like we can try to find DP12. Like if we want to find DP82, like we have a bike with slowness 8 when we reach 2. The way would be start from 1 with slowness 10, go somewhere which where you can purchase a bike with slowness 8, and then go to 2. And let's say if you want to compute DP62, so one way would be start from 10 with slowness 10, go to some node where you buy a node with bike with 8 slowness, and use that bike to go somewhere where you purchase something slowness 2, and then go to 2. Like this is 2D DP, and we will have to decrease it so that everything goes into time. Like solving this DP will take around order of n cube time and it will get TL. So we will have to do something smartly over here as well. Like the next bit I did over here was process in decreasing order of slowness. And for each node, compute the way like the shortest time to reach with, let's say if we have 10, 8, 6. Let's say like these are the three possible bikes we have, where 10 is at node 1, 8 is at node 3, and 6 is at node 2. And if we want to find DP10, 1, 2, or 3, we can take from the starting node, go from 1 to 2, 1 to 1, and 1 to 3 using the shortest path. Now, if we want to calculate like the shortest time to reach 1, 2, or 3 with bike of slowness 8, the way would be go to node 3, say, where you can purchase a bike 8, which would be like here DP and 3, purchase a bike of slowness 8, and then go to all of the other nodes. And once you have calculated DP 8, 1, 2, 3, if you want to calculate DP 1, 2, 3, the way would be either you will have to go to 2 first, using a bike with slowness either 8 or 10, purchase a bike with slowness 6, and then go to all the other nodes from there. Like for example, to reach 3 with slowness 6, one way would be start from 1 with bike slowness 10, directly go to 6, purchase a bike with slowness 6, and then go to 3. Or start from 1, using that bike with slowness 3, go to 10, purchase a bike of slowness 8, go to 2 using that purchase a bike with slowness 2, and then go to again 3 with slowness 6. Like that was the main idea over here. Like any questions on this one? Like so like trying all the combinations will take order n cube time, and for n equal to 1000 that would clearly like we will have to do something smartly. Like we will have to use this idea over here. Like for slowness 8 we have to go to 3, for slowness 2 we have to go to 6. Like we can try to do something over here to get an order n square. Like the main idea is we will just calculate DP SI first and pass that information in order n first. If we compute all the shortest pair, shortest, like if we pre-calculate distance between all shortest distance between all the nodes, we will be able to do a solution in order n square. I will show it using Codeforces. Like first calculating distance complexity is EV log V, and the second part is pretty much order E square, where order V square, where V is the number of nodes. So like I will probably leave Zoom now. Like the time is going to be over, and I will try to code this problem again. First, we will have to take a given graph as input. Like I generally prefer one based indexing, so I will do that. Here I am representing an adjacency list representation. After taking everything as input, I need a distance array Dij where I have found the shortest path between all of the nodes. I can just mark everything as infinity. For that, I will code Dijkstra over here. For that, I will need a priority queue, max priority queue, in fact. Or probably I can also use that to create my max priority queue, because set orders numbers in the increasing order. I first put like source, which is at distance 0 from it, while the priority queue or that whatever we call it is not empty. Constant pop the first element, or probably we can call it top. Remove it from the priority queue, like because I'm using set, the numbers are changed to erase and everything. Now here the node is used, and if the distance we have found so far is less than our current distance, otherwise we have found a new shortest path. And now we should also add the other node. Like this is the code for Dijkstra, and once we run this algorithm, it will compute shortest path between each of the nodes over here. Okay, once we have done this, we can come to a DP array. Like I can probably skip the 2D array DP part over here. Like I start everything with 0. And what we will need is we will have to club all the, like we are not given that all the nodes S are distinct over here. Like it's not given that all the slowness factors are distinct. So we will have to combine the slowness factors with equal values over here. Oh, this made me realize that I forgot to take input of bike slowness. And now we will have to process in the decreasing order of the bike. Because the map is in the increasing order, like we will have to do it in the decreasing order. R begin R end instead of current bike slowness factor and the indexes where this bike is present. Now what we can do is we can try to reach all the bikes on this node first. Like some node with a higher capacity trying to reach over here. Or probably we can say that we have already reached a particular node with that slowness. And now we want to go to some other node using the bike which is present at node this. Like we are at node use and like current time taken to reach this node would be DP node. And now from here we go want to go to some other bike. Distance between node and I and using current slowness factor. And at last we can just print like whatever the minimum time taken for each. So like someone says, my approach for G was using Dixa to compute complete graph that has shortest time from bike I to reach J from node I, and then again using Dixa on this complete graph from node 1. And like probably like did it got clearly or were you able to optimize it into time? And then when you say so for a node we move in decreasing order of all bikes faster than current speed to the other node. Yeah, like that's the idea. Like if we are at particular node, we have reached it using some slowness bike, and we try to reach some node using the current bike. So here I am iterating over the decreasing order. Where let's say if I have a bike with slowness S, then I also note where what all vertices where this node is present, and then I start from all those nodes with this particular slowness, and I try to reach all the other nodes using this bike. That would be time taken to reach this node. Then using this bike, the shortest distance from this node to the other node. So like this pretty much completes my code over here. Oh, that's fine. Like in fact, the sharing approach is better. Like like discussion is important over here. Compilation error was. So yeah, that completes the code. Are there any questions which you want to ask? I can probably spend a couple of minutes, like some people were asking me about setup. I can probably spend a couple of minutes on that, and then we will close this. So thanks everyone for joining. So yeah, like few people were asking me about my setup, so I will spend 5-10 minutes on that, and then we can call it a day. And like for those who are not interested, can probably drop now because I am mostly done with this contest now. Like for my setup, I am using this competitive companion parser over here. Like someone has created it. Like what it does is like it like for most of the websites, if I look at over here, like it supports a lot of websites. Like some of the websites are supported as problem parser, and some of them also support it as a contest parser over here. So like this extension fetches all the test cases from all the problems and sends it to some of the local ports over here. So like there are some default ports as well, like which I was probably not much interested in. And my setup was pretty much like Eknerwala. 1 second, let me. Like these are the two scripts which Eknerwala has written. Like one of them listens on a particular port over here, and like I have some command line LSS over here. Like it fetches all the problems and make folders accordingly. Like there are two scripts: make problem.sh and download problem.sh. What this make file needs is okay. Probably this is one of the. So here I have one dot template directory which contains a make file. This is pretty much the same which Eknerwala has shared. And this template.cpp should contain your template over here. So probably let me make file, and this is my template file, which code I want to be there for everything. And like all of these are in same folder, and this download underscore prop.py runs the script. It looks for some make file, make underscore prop.shl file, and it also needs .template folder where this make file is present and .template CPP is present. And now, like if I like there are some script, like let's say if I say prob a, if I run this prob script with these commands, like these are the possible uses over here. And then if I go over here and click on the plus sign, it pretty much creates a folder where this is my template file, this is that make file, like this is some data which I don't need it, and these are sample1.txt, sample2.out. So like that's pretty much. And then I have some more scripts to run these sample test cases wherever I go. I will probably make a dedicated video sometime, but probably not soon. Like someone was asking, can you suggest something about placement, like how to get into good tech companies with decent package? Like, the question is like, how do you define a decent package or something? But yeah, like, like there are multiple ways. Like the way I did it was like I solved a lot of problems on Codeforces, and like it happened that like a lot of companies only ask like DSA for the fresher. There are companies which do ask development and all, but because I was good at DSA and like some of the companies happened to ask DSA, I answered them, and that was it. Like the way to practice mostly was like I participated in a lot of contests, and like I tried to solve one or two problems more than what I have solved in a contest, and like I pretty much kept doing that, and like it took a lot of time, but in the end, that was the result. So yeah, that pretty much it. So, like it's a tricky question. Like yeah, I just want to ask that development or CP. It's a tricky question. I cannot choose one of the sides over here. And like what I have seen is like people who have chosen development also happen to get good placements. And some of the people who took CP also happen to get good placements. Like you can probably pick the one which you find it more interesting and then try to do. And yeah, like I am a software engineer to at one of the MNC in India. Like I graduated around 2 years ago. And yeah. And like in my case it was on campus placement from one of the IITs. And like the where I was placed, like I was asked DSA only. But like there are other companies who also look out for development. So like it just depends on your preference and what do you like more. So, yeah, pretty much that's it, and we stop now. Thanks everyone for joining. Like, can you please discuss Newton's problem C in short? And give a go through of my code over here, like, because this problem was specifically about code forces. Like I don't want to add Newton over here. Just wanted to keep it focused, but yeah. Like what I did was I first took everything as input, and I did coordinate compression over here. Probably coordinate compression is not required, but you need sorted arrays. Like sorted all the points in the increasing order. Like this is definitely not required. Like just did it because it was initially required. And I sorted all the points. Like what I am trying to do is I am binary searching on the length range, and like once you fix a particular range and you fix the minimum, then you also know the maximum possible value of the length, like maximum possible value as well. So binary search on the length because that's what you need in the end. Then process in the increasing order of the minimum. And once you have fixed the minimum and you have mixed the range, you know the possible range for each of the coin over there. And then for each point, maintain whether which side you can pick it up. Like there are four cases. In your current range, you can't have any of the, you can't keep the coin either upward or the downward, or you can keep the coin as the upward, or you can keep the coin as the downward only, or you can keep both of them. And probably a two pointer like approach where I am maintaining L2 are the range I have of the coins. And here the update operation maintains like number of coins which I can keep upward, number of coins which I can keep downwards, number of coins I can keep both of them, and number of coins which I cannot keep any of the sides. Something over here. And then if there is a coin which I can neither keep upward downward, then this is impossible continue. Otherwise, take minimum as the number of coins which I can only keep downwards because those are the ones which I should flip. For each range, I am returning the minimum operations required and I am binary searching like a max M required over here. Like that was the idea here. And probably like this can probably be the hint, and like you will have to try to figure out all the details over here. Like thanks everyone for joining, and I will probably end this one now.